Hello student. Today I'm going to start new unit number 2, kinematics, chapter 3, motion in a straight line. Now I'm telling you the introduction of this chapter or unit. Concept of motion is known as to every man since he has been observing people walking on the ground, birds flying in the sky, the sun rising in the east and setting in the west. Study of motion forms an important part of study of physics. Statics and dynamics are the two main branches of mechanics, whereas statics is the study of the objects at rest, dynamics is the study of objects in motion. An object can have uniform motion even when no force acting on it. Such forces are said to be in equilibrium. Thus, statics is the study of the motion of an object under the effect of forces in equilibrium. Now, kinematics. What is kinematics? It is the branch of physics which deals only with the description of motion of bodies but not takes into account the causes of their motion is called kinematics. Example: displacement, velocity, acceleration. Now, first terms, frame of reference. Frame of reference. A frame of reference is just a system of coordinates which clearly specifies the position of a particle or an event in 1, 2 or 3-dimensional space. Now, distance. Actually, distance is the length of path traveled by a particle. It is a scalar quantity and SI unit is meter. Displacement. It is defined as the difference between initial and final position of the object. Displacement is a vector quantity. It has direction and SI unit of displacement is meter, same meter. Or another way you can say it is the straight line distance between initial and final position. Now I want to discuss position time graph. Position time graph. When the object is stationary, means rest. If you draw the graph, your graph will be like this. Along x-axis is time, y-axis displacement or distance. Then if you draw the graph will be parallel to the x-axis. I am telling you, see, at any second, any time, the position of the particle is same position. Say distance is 2 meter. If you take 2 meter, then 1 second at 2 meter, after 2 seconds also 2 meter, after 3 seconds also 2 meter, 4 seconds also 2 meter. So ultimately the position remains same, then graph becomes parallel to the time axis. Number 2, for uniform motion, if we draw the graph is inclined to the time axis. Inclined to the time axis means 1 second 2 meter, 2 second 4 meter, 3 second 6 meter, like this. So it is become inclined to the time axis. For non-uniform motion, or bearing, shape of the graph would be like this. Means at different time, different distance is traveled by the particle. Time axis, displacement. Time axis, displacement. Now I want to say speed. It is defined as the distance traveled by the object in 1 second. So speed equal to distance by time. It is a scalar quantity. SI unit is meter per second and centimeter per second in CGS system. The dimensional formula of speed is m0 L t to the power minus 1. Next term, velocity. Rate of change of displacement is called velocity. To understand velocity, I am giving you graph. So at time t1, distance traveled by the particle is x1. At time t2, distance traveled by the particle is x2. The displacement is x2 minus x1. So velocity is defined as displacement by time. So displacement is x2 minus x1 and time interval is t2 minus t1. So it is a scalar quantity, it is a vector quantity, and SI unit is meter per second, and dimension is same with the speed. Dimension is same with speed, that is m0 L to the power minus 1. Thank you.